Hi everybody, we're going to recap the density demo that I did today in class. If you'd like to just kind of revisit those points, or if you missed class, this will be a good way to catch you up and refresh any of those ideas that you might have missed. Okay, so here's what we did today. I had a jar and 3 cans of soda. I also had 1 crush can and 1 empty can. Alright, so we were kind of exploring the idea of what density is and how it actually connects to air movement. Okay, so let's first talk about the density here, and then we'll talk about connecting it to air movement. So the idea is I took these 3 full soda cans and I put them into the jar, and we watched how they behaved in that water. So I had paused here, I had everyone make predictions, and we've got the Diet Pepsi, and it floats. Great. Then we took that out, and I had everyone make predictions about the Mountain Dew. It's the same amount of soda, so everyone kind of was saying, oh, it's going to float also because of blah, blah, blah. It's got carbonation, there's air in it, same amount of soda, same size can, and kind of this happened. So since the title of the demo was the density demo, everyone started making connections. So we started asking questions like, well, why does that one sink and why does this one float? And, well, you know, does the can weigh the same for this versus that? And, you know, what's in this? And so, you know, I pulled out the triple beam balance, and we weighed it. Got an empty can, and we did this crush can, and we found that the crush can weighs about the same as the empty can. Some of you were kind of confused as to why, but I want you to think about this. We have the same amount of aluminum here as here. The only difference is we've smashed more aluminum into a smaller space than we have here. And so in every period it took a little bit, but basically we came up with the idea that density has to do with how much stuff is smashed into a certain space. And the more stuff we have smashed into a smaller space makes it more dense. So this is more dense than this, even though we have the same amount of aluminum in both of these 2 cans. Now on the flip side, we've got an empty can and we have a full can, and then everyone kind of said, oh, well, that makes this can, the one that's full with all the stuff in it, more dense than this soda can because there's less in here. So more stuff smashed into this soda can makes it more dense, and less stuff smashed into this soda can making it less dense. So by talking about that, most of you came up with the idea, well, that means that more stuff in it makes it heavier, and less stuff in it makes it lighter. So everyone started agreeing, and it made sense, right? If you have an anchor for a boat that's hollow and you throw it into water, it's not going to do a very good job. But if we have an anchor that's full of heavy metal or full of cement or whatever your anchor is made out of, and you've jammed it full of all kinds of stuff, it's going to make it heavier than the water, and it's going to sink down to the bottom of the lake and hold your boat in place. So then when I did this and I brought this back out and I put the Diet Pepsi in, and it was floating, and then I put the Mountain Dew back in, a lot of you got really frustrated and said, wait a minute, wait. The Mountain Dew's floating now. What gives? And I didn't mean to, but I accidentally switched jugs because I have 2 jugs and they're very similar. Whoops. Sorry, buddy. But the idea is why does the Mountain Dew float in this one now versus this one? So we had a conversation about the Mountain Dew's got to be heavier than this water in this jar. But there's something funny about this water in here. And I think we had a student blurt out, oh yeah, it's full, there's salt water. Salt water floats. And Then another student said, oh yeah, the Dead Sea is really, really dense and people can float in it. So then we started talking about the idea of density with salt water. And it makes sense if you think about it. We've got more salt smashed into this amount of water, making this water actually heavier and more dense than the water over here. And that means that this is more dense than the soda inside this can. And it forces that soda to float up on top. You can actually see it with the Diet Pepsi. Regular water, the Diet Pepsi floats, but there's room for that to go down about as far as it can, and then the water's like, oh, this is about where I'm going to hold you, right here. This one has more salt in it, which forces that soda can to raise up higher, and you can actually see it when you plop it in here. It's actually so much more dense that it forces that soda can to float sideways, which is kind of neat. So when we get into talking about how air masses interact, I want you to think about, how does the density play a role in how air moves? Okay? If the air is hot, is it more dense or less dense? If the air is cold, is it more dense or less dense? And then what happens if we have a cold air mass running into a hot air mass? Those two different densities, how are they going to interact? So, keep that in mind when we enter into Chapter 5, and happy science. Thanks for watching.